Hi, my name is Ricky Stevens, and I will be doing my project on the coffee mug optimization. So I want to find out what shape mug will minimize the heat transfer from the coffee and thus keep your coffee hot the longest. To solve this problem, I will make some assumptions about the coffee mug. I will assume that the heat transfer is steady state so that the coffee doesn't change temperature. I'll also assume that the heat transfer through the mug is one-dimensional and also ignore any evaporative cooling taking place. And then I will ignore the complex geometry of the mug handle. I'll also assume that the mug is axisymmetric and that the mug is completely full of coffee. To allow for different shaped mugs in my design space, I will approximate the mug shape by slicing it into n cylinders with height dz. Each cylinder will have an independent radius ri, for I is 1 to n. These will be the continuous design variables, dz and ri. The objective function will be a function of these variables and will represent the total steady-state heat transfer from the coffee. The objective function will have terms representing the three modes of heat transfer: conduction through the mug thickness and to the table, convection from the sides of the mug and the coffee surface, and radiation from the sides of the mug and the coffee surface. Using a thermal resistance model analogous to Ohm's law for electrical systems, I can find the equivalent thermal resistance and represent it in terms of the design variables. This will simplify to a nonlinear programming problem that can be solved in MATLAB. I will also define constraints on the design space that will also be functions of the design variables. I will design the volume of coffee held by the mug to be constant for every design. I will also require that the mug be continuous, so no floating pieces. I will then require the shape to be usable, so that the top must be open and the bottom is flat and won't tip over. Then I will impose some reasonable bounds on the design variables. Thank you.